bituminous Nikita, which is going live on YouTube. Hello, Nikita. Hello, Minal.
Yes, ma'am.
Okay.
मैम सबके नंबर पे लिंक भेज दो ना, किस किस को लिंक नहीं मिला है.
So we are now studying a very interesting case, the case of Tallarico Martin Bakery. We are trying to understand the importance of automation in stores and also in the plant or the shop floor. So as I told you, this Tallarico Martin Bakery had a demand for pound cakes, which they were not able to service. So they increased their shift from 8 hours a day to 16 hours to 24 hours, and still they were not able to manufacture pound cakes of standardized quality to service this particular demand. So what was happening? They had a particular setup and they had raw material which was moving into this particular production area. It was very time consuming for them to actually spray certain oils in the trays where the pound cake mixture had to be put uh, in a hurry to work quickly and manufacture large quantities of pound cakes. The quantity of mixture that was put in each mold varied. Sometimes you had larger quantities, sometimes the pound cake was very tiny. And because of this, the output, because of the hurry in the process of production, because of manual labor and the time consuming steps involved in the process of production, and also the time required for bringing the inventory from the stores to the production, there were a lot of problems and difficulties faced by uh, the Martin, Tellerico and Martin Bakery. So what did they do? They adopted a particular mechanization. In this particular mechanization, they uh, tried to bring in mechanization in stages. They first brought in a conveyor where they could keep trays with the mold trays. They brought mechanization for spraying the oil into those trays, and they also brought in mechanization where there was a system where uniform quantities of material could be put into each of those molds. Now, let us understand the executive summary of Tellerico Martin Bakery. So the filling process for pound cakes at the Tellerico Martin Bakery was daunting, time consuming, and had many imperfections. Consumer demand for the product was also continuing to rise. This caused a problem for the bakery that needed to be solved. The options were to increase the operations up to 24 hours shift for the pound cake lines instead of the 8 or 16-hour shift the bakery currently used, or find a way to help automate the process so that it could be done more efficiently with fewer imperfections. So the challenges were many. Why did they want to automate? Because they wanted to work quickly, manufacture larger quantities. At the same time, they did not want to increase the cost of production. So if they were not going to automate completely, they would have to hire larger number of manpower, and then their salary bills or wages bill would increase. So they had to make sure that in the race of servicing the increase in demand, they did not increase the salary bill. Tallarico Martin opted to find a way to help automate the process, reducing human resource or human workforce uh, required to do the job, and reducing the imperfections that cost the company some of their goods. So, because of the lack of automation, there were certain cakes that were not being manufactured in a uniform way. So it was imperative that they moved in the automation way. This allowed the company to save money or increase their supply by putting the same amount of pay towards workers over different shifts, thus increasing the supply. They had to meet the increase in demand. So in this manner, they realized that there was no way out but to move on to automation. Okay, so what did they actually do? We'll see the case. This is the mold, the pound cake filling automation. They had a conveyor in which they put these trays, and then they used equipment to spray the oil and also to put in the liquid. So the filling process for pound cakes at the Tellerico Martin Bakery was daunting, and the Tellerico Martin Bakery opted to find a way to help automate the process, reducing the human workforce required to do the job and reducing imperfections. So what were the issue? With 8-hour shift, 16-hour shift, 12 hours and 24 hours shift, it was extremely expensive and time consuming. Now, so the customer challenges. Even with 8-hour shifts during most of the year and 16-hour shifts during peak buying season, the Tellerico Martin Bakery was facing a struggle to keep up with demand. When human error is included, more issues will come up that will impact the supply. The occasional dropped pan or the spraying process missed a part of the pan would leave occasional pound cakes unable to be packed and sold to customers. This would impact the supply that could be sent out and put more pressure on the human aspect of the process. Now, so what did they do? Let us see the solution. So here, the first thing is they brought in automation. They bought a conveyor belt and they had trays which they put up and they had mechanized ways of spraying the equipment. So we will see the solution. For the Tellerico Martin Bakery, the solution was simple. They needed to expand their operations and include an automated filling station for the pound cake packs. However, there was no such machine anywhere that could do what they needed. So the Tellerico Martin turned to 3 different companies to fix their automation issues. Students, this is a point we have to understand that whether it is the stores or the plant, when we are looking at automation, it has to be customized. And it is very difficult to find one product or one machine that could do all the processes that a particular business organization needs. Because every organization is different. The scale of business is different, their processes are different, the way they run their plant is different. And hence, it is very important for the business organization to pick up automation in the way they need it and customize it for the benefit of that particular business organization. So this is an example just to explain how Tellerico Martin had to turn to 3 different companies to fix their automation issues. The first part of the solution was getting an automated sprayer that could guarantee that each pan would be completely and evenly coated with the non-stick spray. Remember, in bakery, if you do not put oil or the non-stick spray in the pan, then we will not be able to get the pound cake out of the mold. So this had to be done, and automation.
ज्यादा लेक्चर में आ रहा नहीं है, सिर्फ 2 ही
They
जने हैं.
opted to get a Mallet and Company sprayer installed along the line. Six, they wanted a way to deposit the right amount of pound cake batter into each
मैम
pan and give
stop.
the right size pound cake every time. This again had to be automated so that the same quantity of cake mixture went into each of the molds. However, the final solution to this problem didn't exist. No one had a conveyor that would allow these machines to work together
मैम कोई
to
लेक्चर में आया
turn
नहीं
the
है।
pans and return them to the single
सबको
operator
पढ़ा रही है।
who would be used on this line.
अबे
This is
अकेला ही
how
पढ़ा रही
Martin
है।
approached Shuttleworth. Since they specialized in uniquely specialized,
मैम
they had to go to three different
लेक्चर में कोई नहीं है।
one for the sprayer, okay, and then for another one for pouring the cake mixture, and the third one, Shuttleworth, for the conveyor systems. After a bit of ingenuity, a conveyor system was created that allowed one person to run the entire pound cake filling line, where three used to be required, and remove nearly every aspect of an error from this equation. So what do you see when you bring in automation into storekeeping, when you bring in automation into the shop floor factory, we are able to remove human imperfections, we are able to bring in uniformity, standardization, and we are able to turn out good quality, standardized products in large quantities. But of course, when we do automation, we have to look at customization, we have to look at flexibility, and the automation should not be something which is rigid, that cannot be changed. For example, if this demand increased further, the automation that you have selected should be able to step up and cope with the increase in demand, or the capacity enhancement should be allowed. Vis-a-vis, if the demand dropped, we should also be able to contract or relax the system in order to make sure that we are not making it an expensive activity. And therefore, flexibility and customization are paramount when we're looking at automation and mechanization of the factory. So the results, very interesting. Automating the pound cake filling process reduced how much manual labor each person on the pound cake filling line had to do and saved the Tellerico Martin Bakery money. It allowed them to keep up with the demand by increasing the supply as necessary without going beyond their previously established budget for employees' wages. Automation can help improve numerous aspects of the manufacturing business so long as it is used properly. So this was an interesting example where I wanted to begin the entire session by talking about automation and how automation, if it is customized and flexible, helps in a great deal in improving efficiency and reducing cost for stores as well as factory. That is your shop floor. Let us go back to our PPT. Now we will begin with layout of stores. Now, when we look at the stores of a business organization, we must understand that there are certain guiding factors for the construction and layout of stores. Now, stores has to support the production process. In our last class, we studied about two types of stores, that is centralized stores and decentralized stores. Whatever be the orientation of the store, you must understand that the layout of the store is very, very important. Now, when we study the layout, the storekeeper has to actually sit and write down the different categories or classes or types of material that are there in his stores. Then, depending upon the schedule that the production manager sends, he has to understand the frequency of which the certain materials are moving in and out of the stores. While he is studying this, he also has to take an assessment of people, of material that is heavy, material that is expensive, material that is brittle, and certain material that requires specialized methods or ways of storage. In this particular format, he has to plan how he is going to store different material in different places. Now, depending upon certain factors, we have to decide the layout of stores. What are these factors we have to keep in mind while we are designing the layout of stores? These are: first, flow of material. According to this factor, material should move minimum possible distance. So obviously, we cannot have heavy material or large volume material being placed very far away in the store, and the production line is at a distant area, and we have to move these materials from one end of the store right up to the factory. It becomes a very cumbersome activity, time consuming and expensive. So at every point in time, in order to reduce the cost of material, we have to make sure that material should move minimum possible distance. As I explained, the character of materials is very important. While the store's manager or the storekeeper is designing the layout of stores, he has to study the nature or characteristic features of the material. There are certain materials that would get damaged by weather, and therefore they cannot be kept in the shed outside the store. They have to be kept inside the store and very carefully. Like, for example, cement, plaster, and all these things are material that have to be carefully kept inside. There may be certain material which do not corrode very easily, and those we could keep outside the shed, outside the store in small sheds. So we can imagine one main store where material have to be very carefully kept, and then you could have then yards and sheds around your main store where other material which can withstand weather, climatic conditions are kept. So we are now looking at quantity, weight, etc. of materials. It is necessary to find the space required for different purposes. So as I explained to you before, material will vary in quantity and weight, and therefore, keeping this into consideration, we have to plan a layout. Frequency of handling, very, very important. Certain materials are required more frequently in the process of production. Certain materials are purchased more frequently. So if they are getting into production line in larger quantities at a higher frequency, then receipt of these materials from vendors will also be coming in more frequently, and therefore receipt, inspection, storage, issue, all these handling processes have to be taken into consideration while we are looking at the layout of store. Also, the frequency of handling has to be kept in mind. Now, the layout of stores should be such that material may be quickly received in stores. There should be proper unloading platforms. So the approach route into the different bins, areas, racks, and parts of material should be such that goods can move very easily. And therefore, things like planks, things like steps, things like certain machines or racks have to be ramps have to be built in and around the stores so that unloading material from maybe a truck uh, becomes easier and moving it to the place or the bins or the trays or racks where they are stored happens very easily. So it has to be seen that each section of the store has sufficient allotting space. The material is to be arranged in such a way that the inward and outward movement of supplies can be carried out smoothly. Okay, Kirti, can you hear me?
Yeah, ma'am. Sorry
Hello,
for late
Kirti.
coming.
Can you hear me?
Yes, ma'am.
Fine. So we have just finished with a very interesting case study where we talked about uh, a pound cake manufacturing bakery in Chicago and how they use automation in their stores and in their inventory to save the time and energy and increase the efficiency of the workforce and the plant. So we are now discussing the layout of stores, and in the layout of stores, we just discussed about how there are different aspects that we have to keep in mind while we are planning how a store has to be laid out. So we just said all around the stores, there has to be thorough siding, and then we have to make sure that there is space for uh, trucks transporting the materials. There should be sufficient parking space. Ramps should be constructed so that raw material can enter the storeroom very effectively and easily. For heavy materials, suitable equipment for internal transport is provided. Now, throughout my presentation, you will be seeing pictures of different equipment which will be able to handle material that is that is stored in precarious positions in racks that move up to ceilings. Because as we know, uh, the store, every space or every inch of space in a store has to be very effectively utilized in order to have optimum utilization of space and have minimum cost per unit space of a factory. And we need also cranes, ladders, special equipment for moving heavy material. And also internal transport is necessary for stacking boxes, material, and moving them from one part of the store to another part, and also moving them out into the plant for production. It is to be seen that each section of the store has sufficient allotting space. Yes, when we say allotting space, it means space for transaction. What is space for transaction? You cannot just have bins and racks all over. There has to be a place where you will be able to actually stand there and put the material into the bin, and also be able to get material very easily out of the bin and move it out to the space, to the place where they need it. So the material is to be arranged in such a way that the inward and outward movement of supplies can be carried out smoothly. What is a shop floor layout? So far we were talking about the layout of a store. Layout of a store is very, very important, and it has to be flexible, and it has to be in tune with the plant and the different processes that take part in different plants. So depending upon the processes or systems in the inventory, we should be able to service from the factory, from the store, very easily, very smoothly, all the materials to the shop floor. So what is a shop floor? A shop floor is nothing but a factory or a production unit. The primary objective of a layout is to demark the entire shop floor area as per the tasks which are done. So it's important to understand that there are different processes performed in the factory. For every process, there would be machines, and they may be kept in a particular line. So you can have a different orientations of factory, where the factory could be a line oriented factory, where the factory is laid out as per the processes. So, and it is done sequentially. So for production, there could be process 1, process 2, process 3, and then in this sequential order, all the raw materials will move from plant 1, plant 2, plant 3, plant 4, until the product is completely finished, packed, checked for quality, and then moved out to finished goods. Alternatively, we could have a layout where we do not have the factory which is planned according to the series of operations. We could have different processes which happen under one plant. So if there is a welding process that takes place in welding activity that takes place in different parts of that particular product, all the welding will take place under one roof. So that may be one particular plant. Then there could also be a painting or a spraying process which happens several different times for a particular product, which will happen at a different place. So there could be these processes happen in different, so the functional aspects could be differentiated. And then you could have a fixed kind of a layout of a plant where all the activities are happening in one unit. For example, if you are manufacturing or constructing a ship, obviously all the material and everything has to be brought to one point. Or maybe you are manufacturing a boiler, or very heavy equipment, then you have to bring all these processes, all the raw materials to one particular point. So then it becomes a fixed shop floor layout. And then finally, you could have a mixture of this line, functional, fixed, just so that you can customize it to the needs and requirements of your production. So the primary objective of a layout is to demark the entire shop floor area as per the tasks which are done there. Along with demarking, the layout should help in making it simpler for the workers to locate machines, tools, equipment, and other staff on the shop floor. So the importance of the layout of a production or shop floor is to make sure that the people who are working in that particular shop floor find it easy to move from one machine to another, and also that the tools and equipment that they need for each of those processes and tasks are easily available and accessible while they are in the production process. Now, layout of stores or shop floor. Now, if you look at a factory, production unit. This is how it will look. The purchase department will buy the goods and then it will enter the stores and the form of raw materials. The stores will inspect the goods and then take it in. And then it is issued to the work area or the production line, which is also called the assembly line. Once the goods move through the assembly line, they are then sent out for quality control and packaging, and then the finished goods are sent to the warehouse. The shop floor is the production area of any manufacturing facility, which is typically located separately. There are no standard or generic shop floor layouts. These layouts are different for every manufacturing, assembly, or processing facilities. Various types of products or the processes decide the layout of the shop floor. So there is no one blueprint that this is the best layout for a factory. It depends upon your business organization and it has to be customized and flexible. So the guidelines for shop floor building layout. The shop floor building is designed by considering the following guidelines. First of all, most important factor is location of the shop floor. It should be located separately and within the proximity of the design, engineering and the production departments of the manufacturing business. This enables the staff to access the shop floor. So it should be a separate unit and it should be near the location where the workers and engineers can access this particular production area very easily. There should be proper drainage system in the factory, proper waste management system. Most important is safety devices, fire extinguishers in case there are accidents. This facility should also have an eating establishment, restrooms, smoking area, etc. because human beings will also be working side by side with the machinery and they need to be given space for eating, for resting and for relaxing. Health and safety on shop floor is very, very important. We all know the Factories Act and all the rules and regulations have to be followed and the factory should be constructed as per the rules and regulations. The shop floor should be designed with the following: air ventilation, as I explained to you, systems to dispose solid and liquid waste, systems for readiness to any fire hazard, systems provide first aid and tackle medical emergencies, housekeeping for clean and neat shop floor. What is housekeeping? Housekeeping means every day the factory has to be clean. Somebody has to come and sweep the floor, mop the floor, take the dustbins and clean it away, throw it away. All this housekeeping has to be maintained in the factory as well. Store and plant layout. Keeping in view the type of industry and volume of production, the type of layout to be selected is to be decided from the following. First, product or line layout. I have already explained that there are 4 types of layout of a plant or a shop floor. First one, product or line layout, which is the entire plant, the entire factory is set up according to the sequence of processes that need to be performed in each stage. So the sequences, it is one, step two, step three are actually studied, and that step one is the first unit of your plant. Step two is the second unit of your plant, and the raw materials move from unit one to unit two. Processes of functional layer, where we are not looking at the sequence of the activities, but we're looking at process. So you could, for example, if you're looking at a garment manufacturing organization, there could be a drawing process, there could be a cutting process, then there could be an embroidery process, then there could be a weaving process, there could be a finishing process. So you could be doing processes in different units, and then this kind of setup would mean that it's a functional layout of your factory. And you could have a fixed position layout where you're manufacturing goods that cannot move in the line or in the functional way. But everything has to come to one particular central area. For example, we're manufacturing boilers, or maybe you're constructing a building. Obviously, things cannot be moving in a line or functionally, or everything has to come to one particular spot, and things have to be constructed in that way. And then finally, the fourth layout of the factory would be a combination of line, functional, and fixed. So let's just study or understand the layout of the factory. The first one is the product or line layout. If all the processing equipment and machines are arranged according to the sequence of operations of the product, the layout is called the product package. The raw material is supplied at one end of the line and goes from one operation to the next, or packaging, with a minimum working process for it to be done. So, line layout is a very popular format. You can see this picture where you see material, raw material on one side, and for different products, you have different lines. So, you have product A department and product B department. So, according to that product, if you require 8 processes, so you have turning as one process, drilling as the second one, mill as the third one. All the processes are lined sequentially, and the raw material moves from process 1, 2, 3, 4, 5, 6, 7 until it comes to packing, and then it moves to finish goods product. So for every product, there will be a different design, and depending on design, there will be a different sequence that we follow. And the entire factory is laid out according to this line or the sequence of operations. Then this is a picture of product or line layout. The materials come in, there is manufacturing, assembly, processing, packing, and the product goes out. And it is different for each, for different products, depending on the sequence of the processing that happens to each of the products. So there are advantages and disadvantages of each of these layouts. So when you're looking at the line layout or the product layout, so it's, you see the advantages. Obviously, all the sequences are lined up. It lowers total material handling cost because material comes in at process 1 and it moves very smoothly to process 2, process 3 activity. And therefore, this line of product layout has the least total material handling cost because it is moving very smoothly in the serial fashion. So there is less work in processes, better utilization of the machines, less floor area is occupied at moving transit because it is moving from one sequence or one process to another sequentially. Temporary storages, so when you're looking at semi-finished goods or work in process, this storage is very less because it moves from sequentially from one process to another. It is very simple to understand, greater simplicity of production control, and the total production time is also minimized because everything is scheduled very systematically and it would move very smoothly
Hello?
from one process. So there is no backtracking. So after you reach the third process in this line of product layout plan, because you don't have to go back to process 2 until you reach process 4 or 5. So they complete their processes in each unit and then they move from one unit to another. The second, the limitations of product layout.
Lata ma'am.
Now,
Hello.
product or line layout is simple to understand and the plant is set up in a sequential manner. The sequence of the steps in manufacturing. But we must understand that this particular product of line layout lacks flexibility. For example, if you have moved from process 1 to process 2, process 3 with sequential manner, and suddenly there is a breakdown in sequence 3, the entire production
Lata ma'am. Hello.
that means the machinery, equipment, and the human resource that are lined up in plant 4, plant 5, plant 6 have to all remain ideal till there is a correction in plant 3 and then it would move from plant 3 to plant 4. So there is no flexibility, which is required. And this is one of the biggest drawbacks of line of production. Because of this, the
Hello ma'am.
manufacturing consists of all in volume of production. When we say all in
Lata
volume,
ma'am.
if one of the process with production stops, then obviously the output is going to be. If one or two lines are running right, there is considerable machine. Yes. So there is a optimal capacity for each of the units in the plant. And all this will be
Lata ma'am. Hello.
if you're running in these capacities, then it is going to end up with idleness of machine and human resource, which incurs high cost. A single machine breakdown may shut down the whole production. Specialized and strict supervision is essential. So each team of people working in that unit are doing the same process over and over again, and therefore they become specialized. They cannot be shifted to another job. They own that part of the production line, and therefore supervision is also essential that the goods move between one line to the other. Now, we have finished with the advantages, the characteristic features, advantages, and
Hello.
limitations of line of product layout.
Lata ma'am.
Now, we are
Hello.
moving to the second type of layout for a shop floor, that is the functional layout. Now, the difference between a line layout and a functional layout is that this particular layout uh,
Hello.
is a factory where the planning is done as per different operations that have to be. Now, the same type of operations are grouped together under one. Think of fabric manufacturing organization. Now, this is a highly mechanized kind of a factory where SAM is followed. What is SAM? Standard allowed minutes. This is time for completing one rounding, including little extra time. Place all that is factored and standard allowed minute for every garment has to be maintained. Wherein we understand to manufacture a particular garment, there are different processes that have to be performed. There is drawing, cutting, sewing, ironing, washing. It could also be embroidery, weaving. So these are different processes that happen to this uh, raw material, and all those processes will be happening under one unit. So instead of having a sequential manner or making a series of units for the sequence of operations, here we are clubbing different processes under one head and having units in your plant depending upon the type of operation that is performed. Let's try and understand The process of functional. So we finished with line, now we study functional. Depending upon the function that is to be performed after the period, you have the layout of the shop. The process layout is particularly useful when low volume of production is needed. In this type of layout, machines are not arranged according to the sequence of operations, but are arranged according to the nature of type of the operation. This layout is strongly suitable for non-repetitive jobs. Same type of operations is introduced such as lathes will be placed at one place, or the drill machines are at another place as well. Therefore, the process carried out in that area is according to the machine available. So, when we do this kind of a functional layout, it is possible to maintain standard allowed limit, which is an acronym popularly used in the company industry. So, this particular picture that you see over here, capacity of planning, go back to that picture. When you're looking at the capacity of planning, you see the fabric store, which is one function, cuttings room, which is one function, and sewing room. And we have to plan the capacity of each of these processes, each of these functions well in advance. For example, when you're looking at a fabric store, average consumption is 1.4 meters per jeans. So they look at how much fabric will be coming into this particular section and what should be the shelf size where all these fabric can be kept. So for minimum one pair of jeans, how much shelf space will be required. So this is the kind of planning that has to be done when we're looking at the functional layout. Then again in the cutting room, considering the average wedding and cutting
Hello,
time
ma'am.
for
Lata ma'am.
50 files of denim
Hello.
and two-way marker as 2 hours. So in one
Hello,
day
ma'am.
from one table you yield 400 pieces. So this is the way you have to calculate because space is money, time is money. And you have to maintain that momentum of moving from one operation to another. So this particular functional layout has to be done in a manner that everything that has to be done under that one roof or that one plant has to be completed in a particular time span and then it has to move to the next, for example, the sewing tool. So according to SAM, value of each machine, 4 or 2,000 pieces per day, the total machines required are 55. So you have to set your target for your goal. And then depending upon that, you have to do the capacity planning and you have to have a proper functional layout of your factory. So what happens in the functional layout? You have material in, manufacturing, assembly, processing, packing, product moves out. But again, when you're looking at the manufacturing, assembly, processing, it's happening in a functional manner, not in a live manner. There are advantages of process layout. Yes. So what are these? Obviously, what are the disadvantages of the line are the advantages of the process. So there will be less duplication of machines. The total investment in equipment purchase will be there or reduced. It offers better and more efficient supervision to specialization of service. There is greater flexibility in equipment and manpower that load distribution is easy to control. Better utilization of equipment is possible. The exam of equipment can be easily handled by passing just the knowledge. So this is the biggest advantage of process layout. In a line, if one particular process has a particular problem, the entire production line halted. Then, for example, if your cutting section in your garment factory has some particular problem, then the raw material can be shifted to the dyeing section. So the after dyeing, then it can come back to cutting. So there is you can transfer work to another machine. So this is the flexibility, which is an advantage over the line. The breakdown of equipment can be easily handled by transferring work to another machine. There will be better control of complicated or precision processes, especially where much inspection is. So, where the fine work has to be done, not only can control all those complicated or precision processes very easily by having to inspect those plants or those. So now this is a picture where they show the raw material moving in a process layout or a functional layout. So you have forging, grinding, milling, foundry. So they move from 1 to 2 to 3 to 4 to 5 to 6. So these are all different plants. Okay, so you will be having different products. So you could have genes of different types. Okay, so the cutting, the dyeing, if you're looking at garment industry, would be laid out in this particular functional aspect of the unit. All the functions under that unit are performed, but then we move on to another function. What are the limitations of the functional process? There are long material flow lines resulting in extensive handling. Yes, definitely all the different products that have to go through those processes will queue up in front of that machine. So there is going to be a long material flow. Total production cycle time is more going beyond distances and movement. Yes. So if you have finished your cutting and then you have to move to dyeing, unless the previous batch is completed, the dyeing process for the next batch will have to queue up and waiting time can be high. Since more work is in queue and waiting for further operations, this bottlenecks. So though we can say that you can shift from one to the, if one process there is a queue, you can shift to another. In spite of this flexibility, sometimes we do see bottlenecks in the process. Generally, there is we need more floor area because it's are moving from one process to another. And we need more movement space and then we need some processes because once you finish all the processes of a particular unit, all the goods have to be moved on to the next process, which is not sequentially. They may be set up in a big way. Therefore, it will require more floor area to move. Since work does not flow through definite lines, counting and scheduling. If they are not following a sequential line format, the counting and scheduling is definitely challenging. Specialization creates monotony and energy, and there will be difficulty for lay workers to find something. So, when we look at functional setup, only one process, one function is performed in one plant. So, the fact that people working in a plant are doing the same process over and over, they do become specialized in that activity. But if they are laid off, they do not get to find another job in another process because they've already used attained specialization in this. And then uh, these kind of specialized laborers have difficulty in understanding. The third type of plant layout is fixed position layout. As I explained in this fixed position layout, the raw material is neither moving in a sequential manner nor is it moving in functional, but it is fixed in a particular location. So the major component or body of the product remains in a fixed position because it is too heavy or too big, and it is not economical or efficient to bring to move it. And so what we need to do, we have to bring all the necessary tools and equipment to this particular spot. There is huge product is being manufactured, and therefore we have to have a fixed position layout. So this type of layout is used in the manufacturing of boilers, hydraulic and steam turbines, and ships, etc. So these are examples. If you are manufacturing a ship, or a steam turbine, boiler. What kind of a plant layout will you be following? It is following fixed position layout because the parts or components of a ship is so huge that you cannot think of moving the semi-finished part from one plant to another. In fact, everything will happen in one point. All the raw material components, parts, things will have to move to the central production position. Advantages offered by fixed position layout. First of all, material mobility is reduced because everything is happening in one location. Capital investment is minimized. This is because you are not going to have different small plants, and you are not going to have different processes, different machinery, or different equipment set up in different sheds. Everything is happening in one point. The task is usually done by a gang of operators, right? Continuity of operations. So the gang of operators for a particular process for series of activities, they will come, they will perform their process, move the product to a particular level, and then they will move on. Then there will be another set of operators who will come and move the processes to a particular level that we are specialized for and be marketed for them. And finish their task, move the production to a particular level and then move on. So the task is done by gangs of operators and continuity of operation. Production sectors are independent of each other, hence effective planning and maintenance can be done. This total production cost. So each production center is independent. After you got one production aspect, then you move to the next. It offers greater flexibility and allows change in product design, product mix, and production. All this flexibility is available in the fixed position. What are the limitations of fixed position? Highly skilled manpower is required because the gang that is coming to do the particular activity should know their task very well and have to complete it in the schedule that is there. Movement of machines, equipment, production center, maybe time consuming. So the gang has come, but we do not have their raw materials, we do not have their tools, performance parts. Then we will have to wait for all of this to come, and therefore movement of machines is equipment, and we can take to the production center. Sometimes it's time consuming and good for problems. Complicated fixtures may be required for positioning of jobs into display features. So when you're constructing a bridge, when you're constructing a ship, there of course you require highly specialized equipment which is necessary for positioning of the job. And all this will then increase the cost of production. The fourth or the most rational layout of shop floor is called the combination type of layout. So generally the layout used in industries are the combination of above mentioned layout. You rarely see anything which is a line form or a functional form or a fixed form. Today we see combination type of layout which we call a customized layout which will suit that particular feature. So why do organizations do the combination type of layout for the plant? Every layout has got certain advantages that the flexibility is very important. Right? So layout should be such that can be molded according to the requirements of the industry without much investment. If the good features of all types of layouts are combination solution can be obtained, which will be more economical and flexible. So the pillars for combination type of layout are economy and flexibility. So the picture that you see over here is that of a combination layout, a combination of processes and product layouts combined to advantages of all the types of layouts. That means you are designing and functional factors. Now, objectives of stores and plant layout. The objective of a good layout should is that it should provide overall satisfaction to all concerned. Now, who are the people? Who are the all concerned? People who are working in the store, people who are working in the plant, and most important, to the marketing department because they have worked very hard to create a demand for the goods. And until and unless there is efficiency in stores, efficiency in plant, the goods will not be manufactured, it will not be sustained. So we are actually servicing the customer. In order to satisfy the customer, we have to be having very efficient store, very efficient factory, where there is optimization of all the resources. We are able to satisfy everybody concerned. People working in and outside the factory, people working in and outside the production, refinery, we are able to reach our targets and service. Material handling and internal transportation from one operation to the next minimize efficiency. Very important. The material handling and internal transportation. We are going to study this in our next set of slides. We will be able to try and understand what is material handling, try and understand internal transportation, which is very, very important. And this has to be minimized and efficiently done. Wherever possible, we have to mechanize it. The product, the production box, the point of congestion are to be eliminated so that input raw material is semi-finished parts move fast from one location. All bottlenecks in your plant layout. The plant layout should be such that it does not allow for bottlenecks. So raw materials in semi-finished move very quickly and efficiently from one workstation to another. Layout should provide high work in process level, which should utilize the space most efficiently, maybe through the previous organization. So these are the objectives of the plant layout. It should provide workers convenience for job satisfaction and safety for them. It should avoid unnecessary investment capital to help in effective utilization of labor. Should lead to increased productivity and better quality product with reduced capital cost. Should provide easy supervision, should provide space for future expansion, should provide competency and motivation work areas. Now we move on to 6 important principles of stores and plant layout. Very important principles. They are pronounced by Newcomb and they are called the 6 basic principles of best layout. We have principles of overall integration. What is overall integration? There has to be proper connection, coordination, and integration between men, machinery, and people. According to this principle, the best layout is one which provides integration of production facilities like men, machinery, or material, supporting activities, and any other such factors. Yes. Principle of minimum distance. According to this principle, the movements of many materials, because movement increases the cost per unit manufactured. Principle of flow. According to Mosca, the best layout is one which arranges the workstation for each operation process in the same order or sequence. Because in this principle of flow, as the line layout would be very helpful because the raw materials will be efficiency in the flow of the process. Fourth one is principle of cubic space utilization. Very, very important principle. The best layout utilizes cubic space, that is space available both in vertical and horizontal direction. Most intelligently that effectively. Principle of satisfaction and safety. According to this principle, the best layout is one which provides satisfaction and safety. Very, very important. If there is no safety, that there is no satisfaction, then job will not be done with efficiency and principle of flexibility. Most important is in automotive and other allied industries, the models product change after some time. The principle of flexibility provides adoption arrangements at a minimum cost and least people. So when we are looking at stores, we are looking at factories, we must understand that these have to be most flexible because the models of the product design change very frequently as per the user preferences of the customer. And the production or technology method processes change from product design to product. Therefore, the way of going to store the raw material, the manner in which you are going to plan your inventory shop floor should be something flexible, easy, and efficient. So the principle is very, very important in the planning store. So these are certain uh, websites that help you compile this slide as well. I thank you for participating in this first part of my session today. Now we will move on to the next session. We will talk about material handling. Material handling and store layout. So what are going to see in these set of slides? When we talk about material handling, we're talking about material and how they are moved from the vendor to the store and how they move from the store to the shop floor and from the shop floor to the finished goods and finally from finished goods to the market. So whether it is raw material, semi-finished goods, components, parts, tools, jigs, or whether it is inventory, finished goods moving to the market, we will refer to them as material. They are being handled because they are moving from one place to another. In fact, material is handled inside a store also. After the material moves from the vendor to your store, they are moved from the store to the production house or from the store from one place to another. All this will amount to material. And it is very important to understand that material handling has to be done in a very logical and rational way so that we reduce costs. In our previous slides, we have understood and studied that if we increase material handling, material traveling time, material movement, increases in the cost of production. Therefore, we have to have a scientific store layout. If you have a scientific store layout, you will be able to have an efficient material handling. You will be able to plan for efficient. While we are at this particular point, when we are trying to understand what is material handling, we have to take a lens from our previous learnings where we said that we cannot just think of labor or manpower. Earlier on, labor, whether they were skilled, unskilled, semi-skilled, or specialized, all of them were pushed for handling machines. So they were people who were running machines, people who were trained or highly skilled labor were also pulled out and asked to continue. Let me tell you, students, that this is a very unscientific way of running a slave. Because this particular labor that is specialized should be used for their specialized activity. The money that you pay them per hour is for the specialized activity that you have. If you are going to use them for unskilled activities like a handling labor, it is going to result in higher labor bills for you. So it is very, very important to have a correct mix of labor and mechanization. So depending upon the size of your factory or the quantity that you manufacture, the scale of operations, you have to have an optimum or the best mix of labor and automation. Sometimes automation is not feasible, but we have to customize automation, like I explained in my case study, the case study with you that when you think about machines, equipment, it has to suit the need of what factory or your shop floor or your store. And it has to be something which is improving or increasing the efficiency, the productivity of your factory. So what is material handling? Material handling is a science and art both involving the moving, packing, the storing of substances in any form, and includes the preparation, placing, and positioning the material to facilitate their movement or storage. This is what I try to explain, that any kind of material, when you're looking at material, we have to also think about planning as to where you're going to keep that material. You have to also think about packing that material, while it is in transit, while it is sitting in storage, and also positioning that material while it is loaded onto transportation, how you're going to unload it. All this is something which is studied scientifically. The meaning of material handling. We are going to try and understand what is the meaning of material. In this slide, I have shown you certain pictures where I have explained that manpower versus mechanization. And we're looking at manpower, I think you should have automation when you have large scale production, increase inventory, because that is more rational and also more humane. Is now very unsafe to have labor to pick up heavy oxygen equipment because we can put the back sorry. And that is not what we want for our labor force to suffer. The material handling occurs whenever material is moved, maybe in the manufacturing, distribution, or warehouse, office environment. Materials handling also occurs during preparation for shipment, transportation maybe by sea, air, or land, and moving materials in our carriers. So, in all these contexts, this way material handling occurs. What are these contexts? In the manufacturing organization, you need raw materials, components, parts, semiconductors, waste, food. So you need materials. So there may be business organizations that are not manufacturing, but they are buying and selling. So even if they're doing distribution, they do need the process of material handling. Because you need a warehouse, you need to buy material, you need to stock it, and then you need to transport it to the market. You also do material handling when you are in an office environment. Because in an office also, you require to buy materials or materials. So, be it in manufacturing, distribution, or office environment, and activity. So this also occurs during preparation for shipment. Shipment means transportation. So when material is moved from one place to another, maybe by sea, air, or land, moving material in and out of carriers also amounts to material handling. What are these carriers? It could be trucks, it could be ships, it could be aircraft, all this moving material into and out of all these carriers will also come under the material handling. The definition of material handling. Now, the International Material Management Society has defined material handling as materials handling is an art and science involving movements, packaging, and storing of substances in any form. So, what are these? Movement, packaging, and storing of substances. All these things will come under the purview of materials. Now, in this slide, you see different equipment which you can have inside your very huge store, which can help you move your material to a particular bin or rack and also move it out of that rack and take it to production. Objective of material handling. The main objective of material handling engineering is to reduce production. So materials have to be handled. You cannot just say that they come to your production house and it is not by there. You have to handle it, but while you handle it, the more you handle it, the more the material is handled, higher is the cost of it. And therefore, the main objective of material handling is to reduce. Materials handling is not production machinery, but it's auxiliary equipment that improves the flow of material, which in turn reduces stoppages in production, and thus increases production. So, if you want to improve material handling along with labor, you also have to have material handling equipment. So, this material handling equipment is termed as auxiliary equipment. So when you are purchasing raw material which gets into the production unit, remember that in your store you also have to have space and you have to also store auxiliary equipment. What is auxiliary equipment? It could be a ladder, or it could be a slide, or it could be a particular car which is moving from one place to another. All this transportation materials will come out to the equipment, and your stores have to also be stocking and taking care of auxiliary material along with material that gets into the production. The objectives of material handling. Now, reduction of cost, increased capacity, improve working conditions, improve customer service, and improve productivity. These are the 5 objectives of it. So if you are the store's manager and you are responsible for material handling, you want to first of all reduce costs. You want to increase the capacity. So you have a store, you have to keep your plan really out of your store. When you plan it properly, you are increasing the capacity. When you increase the capacity, it means you are optimally utilizing the space in your store and therefore making it less expensive. You are making sure that in the store you have improved working conditions. When you have improved working conditions and the labor is not used excessively, there is a happy mix of mechanization and manpower, good working conditions, lighting, ventilation, air conditioning, cleanliness. Improve customer service. What is customer service? Our customers is the ultimate person who has to be satisfied, and all the customers, that is the storekeeper, the production manager, the marketing manager, all have to be happy so that it would reach the customer in time. Improve productivity. At any point in time, production should not be hampered due to faulty material handling. You have scientific material handling, which means that the material components and parts are reaching the production line as per schedule, and it is supporting production to reach the targets, and therefore service. Objectives of material handling. First one, reduction in cost, reducing material handling by improving handling procedures to more. So if you are looking at the first objective of reduction in cost. What do you need to do? You have to first of all reduce material handling. You have to improve material handling, and you need to do both of these. So reducing material handling work. Material handling work should not be assigned to skilled or semi-skilled. Reducing indirect labor expenses and activities connected with storage, inspection, quality control, repair, cleaning, shipping, etc. All these indirect labor expenses activities should also be reduced. Objectives of material handling reduction in cost include reducing damage induced during handling, better utilization of space, reducing process storage, increasing productivity, reducing expenditure on packaging and other productive devices, and decreasing inventory. We have to maintain as much stock as we need. So when you come to order level or re-order level, that is when you building your material, you overstocking on material. Make sure that goods are not damaged while they are being handled. When are they handled? Then you append or add materials to your bills and trade, or you are withdrawing material to sell production as per schedule. Better utilization of space in your factory, reduce process storage, increasing productivity, make sure that there is efficiency in all aspects of your stores, reducing expenditure on packaging. While protective devices and packaging is very important, you have to make sure that there has to be optimal utilization of packaging. If you spend too much on packaging, you increase the cost of the product. Increasing the capacity, improve materials handling, this will result in increase of capacity by better utilization of space. Improve handling systems and increase the capacity of the following: better utilization of space, racks or containers, and stack items, for which are making full use of aspiration to the product. From this point of view, use of overhead cranes, conveyors, lifts, etc. should be increased. By reducing travel space or excessive wastage of space. For this purpose, the study of flow materials within operations should be done. This study will help in reducing travel time and space by improving equipment utilization. This will reduce idling of machines by faster loading or unloading. This can be achieved by employing conveyor systems, grading loaders, grading cars, trucks, etc. Improvement in working conditions. The safety aspect has to be taken care of. Safety of men, material, associated equipment not only prevents loss of money but also enhances the environment. Very, very important that you keep your men and material and equipment. Materials and equipment very safe in your organization. Easy working. By using proper handling equipment, heavy jobs can be easily used. Faster speed and at a constant rate throughout the period of production. This rate is high, morale is lower, workers full-proof operation. Due to absence of manual handling, there are no chances of confusion resulting in tracing of material long negotiation. Very, very important. When you have mechanization, the human error is eliminated and makes your system more efficient. Improve customer service. Customer services will be improved by following proper and improved material handling systems, including regular time to market supply by avoiding disruption. These are the main sources of good customer service. So we are finished with the objectives of material handling. Very simple and very important from example. And also coming next are 20 principles of material handling. Very popular France design point of view. These principles, we will first run through the principles. We will discuss those principles and then we can go through the 20 I would also like to have some personal update. This was related to planning systems principles, simplification principles. Now, these principles are all related to planning of planning systems, simplification, flow, unit size principle, space utilization principle, and safety. There are 8 principles and there are principles related to planning. Then you have principles related to equipment, which would have mechanization, flexibility. Equipment selection, standardization, lightweight, motion, idle time, obsolescence, maintenance, finite principles related to operation. Control principle, capacity principle, and performance. So there are 3 categories under which these principles of material handling are down, and we are going to try and understand what these principles are. So let's begin with principles of material handling. We have systems principles. Under systems principles, handling activities be integrated and coordinated. So when we're looking at handling, integration will come under systems principles. Handling activities are receiving, storage, in-process handling, inspection, packaging, warehousing, shipping, transport. Consider all the handling activities like delivery, detail, execution, material flow between work areas of plant, integrated activities into the handling system is necessary. The simplification principle, very important in material handling. When you simplify the entire process, we are looking at reduce, combine, or eliminate unnecessary movements. Very important. When we look at motion economy principle, we have. Now, when we look at motion economy principle, it means that we have to make sure that we are increasing the cost of the material when we are moving there. So if you're going to make sure that our labor bills are kept very less, if we bring in the optimum level of mechanization with labor cost, it will result in motion. Reduce or eliminate long and complicated material like spot because instead of making it complicated. We have to eliminate rehandling of material, and we also have to reduce variety of equipment. So if the goods are moving in one particular vehicle, they should, from the point of start to the end, they should be that. So it's important to shifting them from one equipment to another. Material flow principle. Material flow principle or pattern must be determined by operation, input and pattern. Therefore, make sure that there is no overcrowding. If there is any material that is obsolete or outdated, we have to make sure that that is taken off from that quantity so that there is no obsolete or obsolete material and also overcrowding material from that. We have to move in a direct path and avoid backpacking. Move greatest weight about or bulk or distance. Minimize movements between floors and buildings. Plan proper locations of sub-assembly. Plan related work areas close together. Avoid traffic jams and take necessary precautions for cross-traffic. Principles of material handling, we have practice principles that utilize certain equipment that follow their